Hello, K-Squid listeners. It's every other Sunday again, and you're listening to Sustainability Now, a biweekly K-Squid radio show focused on environment, sustainability, and social justice in the Monterey Bay region, California, and the world. I'm your host, Ronnie Lipschitz. Longtime listeners to Sustainability Now know that we periodically turn to a focus on plastic, whose production is predicted to skyrocket over the next few decades as fossil fuel companies look for ways to sell their product. Plastics are not forever, although they last a long time in the environment and are piling up across the world's lands and oceans. Even notionally compostable plastics require special handling if they are to be returned to their constituent components, and most of these plastics are not handled specially. If you could make a better plastic, one that would decompose into biological carbon in your backyard compost pile, wouldn't the world beat a path to your door? Maybe, maybe not. My guest today is Raegen Kelly, Head of Product and Sustainability Lead and co-founder at Better for All, where she works with biopolymer engineers and manufacturing experts to create a unique line of PHBH home compostable bioplastic cups that can break down with minimal treatment in your backyard compost pile. Prior to Better for All, she produced creative projects for USC Annenberg, Warner Brothers Records, the Los Angeles County Museum of Art, and Otis College of Design. We're going to talk today about why it is so difficult to get the manufacturers of plastic and plastic products to use PHBH and what Better for All is trying to do about that. Raegen Kelly, welcome to Sustainability Now.
Thank you. It's a pleasure to be here.
Why don't we start with some basic information? What is Better for All? What are its goals, and what is the company doing?
So Better for All is the trademark of a company called Geosphere. We're based in California, and for the past 5+ years, we've been working with compostable and bio-based materials to replace some of the more pernicious plastic packaging and single-use product waste. Better for All, and specifically, has taken on the single-use plastic cup. And we are working on a line of compostable cups that are certified home compostable, made from a PHA known as PHBH.
Okay. And then who are you, and what is your background, and what do you do for Better for All and Geosphere?
So I am the head of product and also marketing. We're a startup, so I wear several hats, but my primary focus is product. So my job is to develop new material sources and find good applications, and then find the manufacturers that are willing to work with these materials to make them into something we can scale up and make affordable.
Mm-hmm. Mm-hmm. Why don't you tell us about the problem posed by plastics in general? What they're made from, how they're made, why are some plastics claimed to be compostable and others not?
Right. So, so most plastics until, recently have been derived from petroleum byproducts, either natural gas or oil. The oil or the natural gas is processed to create building blocks of plastics. It's a naphtha. It's a really highly flammable substance.
Mm-hmm.
They can then be cracked into all kinds of chemicals and the building blocks of plastics. The upside is it's this highly stable, plentiful at this point, readily available material. But the downside is also that it's so stable, right? We've pulled
Mm-hmm.
it deep from the
Mm-hmm.
earth, and it's really hard to get it to go away once you've produced it. So there have been a number of initiatives, in the most familiar one being PLA, to make plastics that function very similarly to petroleum-based plastic, but are derived from biological resources and are inherently less stable, meaning that they'll break down in a number of years instead of decades or centuries. PLA is derived from corn sugars. It's chemically processed corn sugars and I think beets. They use all kinds of inputs. And PLA is really good for some applications. It makes an incredible 3D printing resin. There's all kinds of ways that PLA, after about 30 years of scaling up and gaining adoption and figuring out its kind of best happy applications, but PLA is only industrially compostable. So there's different time scales okay, let me start again. There's different types of compostability. Some things can be composted in a regular home composter and will take about, I don't know, 6 months, sort of like a avocado peel or a banana peel or something like that. Some paper takes a long time to break down in your home composter, but they will completely biodegrade into their original sort of molecular building blocks. Other materials need very specific temperatures, moisture, and microorganisms in order to be fully digested and broken down to their natural building blocks. And PLA is one of those things. Around the same time that PLA was being developed, there were other companies that were working on PHAs. And PHAs are derived by feeding, you can feed all kinds of inputs, but carbon-rich in feedstocks, in some cases, vegetable oils, you could use seawater, you can use all kinds of things. People are working on wastewater, methane. Anyway, these feedstocks can be fed to microorganisms that are commonly found in soil, and they will go through a process of fermentation if the setting is right, the temperature, there's enough moisture, etc. They will ferment these inputs, and one of the outputs are the building blocks of PHAs. So PHAs, because they're made by microorganisms, in part to be consumed later, the products made from PHAs are readily consumed in a composting environment. Hence, this second generation of compostable bioplastics that people are looking to in part solve the problem of environmental waste that's not necessarily properly even deposited in a landfill, but escaping into the environment and then lasting for decades and causing all kinds of wreaking havoc essentially on our biosphere.
So that's PLAs, right? Not the PHBH, right? What you're just talking about.
No, just regular plastic, right?
Yeah,
Regular plastic is just a huge problem.
Yeah.
I mean, I think we all know this at this point.
So the PHBH basically breaks down at low temperature because it's being consumed by the same kinds of microorganisms, right?
That's right.
And they, of course, operate at relatively low temperatures. And where do you get your feedstock?
So the feedstock that we currently get is from a company called Konica. It's a large chemical company that makes all kinds of things, but they've been working on developing a PHA for probably 40 years with the hopes of building that into a major cornerstone of their business. They set up their headquarters in Houston, Texas for the biopolymers division. So we work with Houston, Texas-based company called Konica Biopolymers, and they produce PHBH. Currently, they're producing in Japan, but they're building a factory in Houston. So we also manufacture in the US. So that's another nice sort of tight supply chain that we're building. So things, so we cut down on freight and all the other issues that you have to think about.
There must be some irony in their setting a business in Houston.
A lot of the sustainable solutions are setting up house in Houston.
Really? Good. Yeah. Well, I want to talk. Before that, I want to ask something about the production chain. How are plastic items manufactured?
Well,
we know what the feedstock is, but what form does it come into the factory, and what happens to it then?
Okay, so plastic almost 100% of the time is exits the plastic production facility in the form of pellets, these really small little pieces of virgin or pure plastic resin that has a very specific melting point, specific handling instructions, and when it's received by the converter or the product manufacturer, those plastics are essentially put into a big gaylord that feeds the plastic into a machine that heats the plastic, melts it into a fluid that then is typically molded. And there's different molding types. We use injection molding, where huge amounts of pressure are applied, two sides of a mold come together, and plastic is injected into the mold,
right.
like subjected to you can't actually, the thing that really blew my mind was how much steel and concrete we use to make these tiny, tiny, tiny pieces of plastic. Like, it's incredible how much money goes into the molds, the machines, the real estate that has to be committed. Anyway, and then the other processes are thermoforming, which is how most plastic cups are made. And that is you take a sheet of plastic and stamp out the product, so you get a really lightweight product. There's a lot of waste built into thermoforming, which is one of the reasons we didn't choose it, because whatever isn't punched out gets thrown away. You can sometimes recycle it, but like red party cups can't be recycled, and a lot of bioplastics break down if you put them through too many cycles. So then there's other manufacturing methods, but the one we use is injection molding.
Yeah, I actually worked in a factory in Israel 50 years ago that made plates and cups and other kinds of things, melamine. And I'm trying to remember, I remember working with the presses, and I'm trying to remember what the raw material was and how it worked. It escapes me right now. But one thing about these factories is that they're set up to use certain kinds of inputs, right?
Yeah.
It's not just a matter of any plastic can go into the factory, any particular, virgin material, and operate with the equipment that's in there. So there's a fairly big investment in infrastructure, so to speak, right? Which the manufacturer has to somehow recoup.
Right.
Yeah.
So I would say that the task. So some of the real big challenges for people trying to replace, right, petroleum-based non-compostable plastics is that we need to develop materials and find ways to use materials that can work within the existing manufacturing infrastructure, because it's so expensive to set up a factory, and also it's incredibly wasteful to throw all of that away and start from scratch. It could be amazing, but the fact is, you and I both know that even if we invented a perfect world, we'd make mistakes, right? And it would take a really long time to get there. And we're trying to deal with a problem that's really urgent right now. So I think a perfect example is Lego has been looking at so many different inputs. I've been tracking their progress. They've looked at every possible bioplastic. They've looked at recycled resin, et cetera, et cetera. And they finally rejected recycled resin because it would require them to replace the equipment at their factories, which would be a bigger carbon impact than using a recycled material. Now, I don't know. I'm not going to say I agree or disagree. I'm just saying that, like, when you look at all the metrics that we're using right now to evaluate whether something's a sustainable decision, it's, you really do need to be able to use the equipment at hand. So we are running on regular injection molding equipment. Of course, there's a lot of considerations. For example, we need really extremely high pressure. The viscosity of our material is different than most petroleum plastics. So we need the larger machines. We need molds that are much more able to clamp down and hold on and resist that much pressure. We need really carefully constructed interiors of the molds so that the material doesn't overheat and shear, which means it'll weaken during injection. So you definitely have to put a lot of work in at the development stage to figure out how to use what exists to make something better. But we are doing it. And you definitely need manufacturing partners who are either incentivized by subsidies or something, which isn't quite there yet, or who are just invested or have customers who are invested in finding better materials for their products.
You're listening to Sustainability Now. I'm your host, Ronnie Lipschitz, and my guest today is Raegen Kelly, who is head of product and sustainability lead and co-founder of Better for All, a company which is trying to popularize the use of a easily compostable plastic in this case, in cups, drinking cups. I want to quote a recent San Francisco Chronicle article about Amazon drones, which doesn't sound quite appropriate, but there was a quote in there. It turns out the drones have been successfully delivering cans of soup and chocolates and bags of nuts, but that's all they can do. But in the article, Rodney Brooks, who is described as a robotics entrepreneur and frequent critic of technology companies' hype, says, quote, "Having ideas is easy. Turning them into reality is hard. Turning them into being deployed at scale is even harder." And I gather this has been your experience with this. I mean, when we talked a couple of months ago, I think you said you've been doing this for 4 or 5 years. And
Yep.
I'm quite interested in hearing about, what you've learned from trying to turn ideas into reality about the slog. And I think the issue of the infrastructure, the built infrastructure for making plastics, is a great example of one of the issues that nobody ever thinks about when they say, "Oh, we have a better mousetrap."
Yeah.
So I would like you to talk about that at some length.
Yeah, absolutely. Yeah. I mean, the scale, I think for me, scale, like comprehending scale, has been one of the biggest learnings that I've taken from this particular job. One, comprehending the scale of the problem, and then finding a niche product or a product that people can relate to enough that they may adopt the change and become promoters of the change, on their own, right? Like, how do we started out with bags. A lot of people do, right? We started out with bags, and we quickly realized that not only are bags like a fraction of a penny is what companies are paying for bags, and that's all they want to pay. And so it's very hard to put a new, more expensive material into that scenario, that supply chain. But also, people just rip bags off and throw them away. They have no moment at which they take a minute to consider what it is that's in their hand that they're throwing away. So I think part of it is like, how do you pick something that is used at large enough scale that if you achieve the impact, or if you achieve the market penetration that you're seeking to, you will have a real impact. So we started with bags, we shifted again, and then we landed on the cup, because a cup is something that, one, I think I didn't realize this, but for example, billions of, things like red party cups are thrown away every year, and they can't even be recycled. Yeah. And they're also made from one of the more toxic and pernicious plastic materials. So it just felt like a great thing to take on. But also, it's something that people connect to. It's a cultural reference at this point. I mean, if you see a movie and you see that flash of red, you know that people are at a party, right? It's been really well embedded in the culture. Mm-hmm. And so there's an opportunity there if we can take advantage of it. And I can feel the momentum building towards, just in general, towards like, okay, so we know we need to find something better. What is it, right? Like, that's definitely moved. The needle has moved a lot in 5 years. But I would say the other thing is that material supply is a huge issue. I went to PHA Congress a couple of weeks ago, and they talked about, like, we had Pepsi and all these big CPG brands were there. And, I've worked enough with CPG brands on the sales side to know,
what is
that sometimes they're saying,
what is CPG?
Oh, I'm so sorry. Consumer packaged goods.
Okay.
So just the big brands that pump so much of this plastic into our worlds, right? Pepsi, for example, I just read this morning, Pepsi's being sued by the state of New York, counted thousands of pieces of trash along the Buffalo River, and 17% were branded Pepsi, and they're being sued. Wow. They were also at this PHA Congress talking about all the things that they've been trying to do on the back end to adopt PHA as their material. And when they talked about the at the amount of material they would need to replace all their chips bags or whatever, you couldn't replace all the chips bags Pepsi puts into the world right now with the PHA available, even if you combined all the PHA available worldwide. So that's an issue. So it seems to me that, it's a bit of a cat and mouse. We need to create demand and get a few large players to regionally adopt some of these solutions and commit, right? Not pilot and then go back to the marketing group and say, okay, make sure you let everyone know we did this pilot and we're going to do a study now for the next 8 months and then pilot again, right? They actually need to commit, and then the supply will catch up. Right now we're up against petroleum, processing plants are literally dotted across the globe. And so It's really easy. Also, we've been growing in the US, we've been growing our supply of petroleum plastic resins and exporting more and more yearly, right? We're exporting a ton to places like Africa, et cetera. And, we're just essentially exporting the problem. I don't know if I'm answering your question very well, but yeah, go ahead.
No. I mean, it's if you think about this, the whole sort of supply chain issue, right? The production of the raw material, I have no idea. I mean, I've looked at diagrams that show what's involved, right? But I have no idea how you can do this at scale, right? I mean, or in large volume, right? I'm presuming, I don't know what the company in Japan, what scale the company in Japan is operating at. I know that about 5 years ago, when I and my colleagues at our nonprofit started looking into this, we talked to a company in Oakland that was trying to do some kind of PHA. It seemed like a no-brainer.
Right.
Right.
So there's a lot of small, I would say there's a lot of small operations that are really doing cool things, honestly. And I think that eventually that will be the way that we make PHAs or whatever it is we make. But right now they can only make like a pound a week. It's really at the, it's seaweed, I think there's so many amazing seaweed initiatives out there, and some are further along than others. So they can do coatings and things like that for very specific applications.
I often wonder about how much seaweed is actually out there.
I think they're incentivizing farming, like seaweed farming. A number of sort of shell fishermen and so forth are converting their operations to seaweed farming. Again, I have no numbers about like how large this movement but I think it's pretty substantial. And there's quite a bit of regional seaweed farming happening off the coast of Africa, et cetera. So I'll say a couple things. One, I think we need a diversity of material inputs. We see this on the energy side. We cannot rely on one input for anything. Diversity is really something I think about a lot. So let's cultivate a whole range of material inputs. The US is very good at funding innovation. We went to Caltech, which is right down the street from us, a couple of years ago, and there was a lab, and they had made this incredible material out of discarded nutshells from the Central Valley in California. California grows the world's almonds, for example, pistachios. And they have these mountains of shells that are like rigid. They have all these built-in characteristics that we could use. And so they were building a replacement for particle board. That's really clever, like maybe, it's now in a lab in Caltech, but that IP, once it's developed, could be scaled up by a corporation or something like that.
So just to get back to this idea then, right? Yep. So you've got to have some sort of input material in sufficient supply. I mean, we can assume that there is a lot of biological input, right? That would be available. Again, there's always the question of what are the alternate use? How are those things being used now? And so there's the conversion, the creation process to do that in volume. And then, and there's a competition point, which is that oil is relatively cheap, especially if you're making things like plastics, right? And there's a lot of it, and the oil companies are going to have to, if they want to stay in business, they're going to have to find other ways to use their their
Right.
resources, right? And then there's the
Then,
production part of it,
right.
right?
Right.
And then there is the distributor demand part of it,
Yes.
right?
Yeah.
And then
Yeah.
there is the consumer part of it,
Right.
right?
And then there's the end of life.
And then there's the
Right.
end of life, right? But we're
Right.
we're being hopeful that in this case people will throw the stuff into the right bin, and somehow or another that will be taken to low temperature composting facilities, right? I mean, it's a long chain, creating the demand. It
Yeah. So
seems to be.
I believe the demand is there.
Well,
People want solutions, but I would say that there's two parts there. So we did talk about how manufacturers, we are using existing manufacturing processes and
right,
machines
right,
to make our
right.
products. However, it is true that you referred earlier to, the fermentation vats, for example, that you need to
Yeah,
make a PHA, that those are not in existence right now.
right, yeah,
Those
sure.
have to be built. That infrastructure has to be built, just like they had to build all these petrochemical plants and are still building them, by the way, all over the coastline of Louisiana, all the way down to Houston, right? We will need to build infrastructure to create some of these materials. I would say the scrutiny that was never brought to bear on petroleum plastics is triply being brought to bear on anything new. It's frustrating sometimes, I will say, but it's also really good. Like, is this toxic? Does this have something in it we're gonna find out in 15 years is causing cancer rates to go up?
Hmm.
All the things we know are happening because of the existing materials we're using.
Right.
Because this scrutiny is being brought to bear, we're also really looking at inputs. So you mentioned, right now our product has a vegetable oil input. Yes, they can make it from used cooking oil. The scale of the used cooking oil they can get a hold of and then
Right.
clean, right? There's always that issue, right? But what's being cultivated are PHAs that are being made by injecting methane or carbon dioxide or like wastewater. Wastewater, you can make PHBH or PHA using wastewater. So there's
Mm.
thinking going into how do we make a circular material production process? How do we build enough capacity? And then what are the best applications for these products that we make? And
Right.
then I would say the distributor part, cost is the issue because one, petroleum is just massively subsidized. I don't think we really realize how many of our tax dollars really act as a coupon to the petroleum industries. I mean, they essentially just get a big giant discount every year. 50 billion was what I think Tim Scott mentioned in a congressional hearing. It was like, that's just cash right off the top. Those subsidies are not operating yet for new materials. There are grants and energy, right?
The subsidies are long entrenched.
Yep.
Right. And I mean, I know everyone talks about eliminating subsidies for oil companies in order to make renewables more competitive. Right. And
Uh-huh.
and there's, some subsidies are slowly coming in, although again, the scale is is
Mm-hmm.
is nowhere near, right? But if you want to do new subsidies, it's much more difficult now, right? I mean, in the
Yep.
sense that the,
Yep.
the oil subsidies were put in, under the sort of guise of national security. And
Exactly.
and it's hard to argue that cups and plates
Yep.
involve that kind of urgent concern, however real or fake it might be.
Well, I would say, I guess you have to think about whether you consider global warming to be a national security issue. And I really do.
I mean, that's a
I don't,
that's a whole
yeah.
different topic, and we should touch on that. You're listening to Sustainability Now. I'm your host, Ronnie Lipschitz. My guest today is Raegen Kelly, who works at Better for All, a company that's trying to popularize and distribute truly compostable plastics, things that you can throw in your backyard compost bin, and 6 months later it will come out as soil. And we've been discussing a lot of the obstacles to basically changing the supply slash product chain from raw material to production to consumer and to disposal, which in my mind is actually much more interesting than talking about the stuff itself, because those are the kinds of things that have to somehow be overcome or addressed in order for this transition to take place. Where were we? We were talking about, I was talking about subsidies, and that's part of the politics. And you brought up global warming. And one of the things that economists talk about a lot are externalities, the costs that are imposed on people or on the environment, which are not internalized in the cost of goods and services and processes. Right. And I mean, I imagine that one could think about this, the comparison between non-compostable plastics and compostable plastics over the long term, as you suggest, in the case of climate change. If you could monetize that, which is what people have tried to do with carbon credits, you might be able to sort of to force the market to change, although that hasn't been terribly successful.
No, it hasn't. Yeah, I mean, I honestly just believe that, we need we need such a massive paradigm shift.
Yeah,
And,
sure.
the way we look at our company and our product or the way I look at it is we're at the very early stages of building momentum towards a paradigm shift. And
Mm-hmm.
I was thinking about this interview last night and I thought, what would be, you said something like in 2050, it's going to look very much, if you're thinking just in terms of transportation,
Well,
like it does today, right?
right.
Right. And
And
like we're putting cups in people's hands that they're going to throw in hopefully a compost bin, and it's going to look a lot like it does today. But the paradigm shift, the part of the paradigm shift that I'm really utopian about is that right now, can we design out landfill? Really is kind of the goal, right?
yeah,
Can we design? Now we have all these products that we're stuck with that people use, that there's like a host, thousands of businesses are based on the existence of these plastic products, these
right,
cups, these plates, these, right?
right.
And I don't want to put all of them out of business, right? And I also don't think that most people can afford, a fancy stainless steel container and carry it around with them. Do you have a car? Like I don't know. There's just so many components when I think through this thing. So can we start to incrementally change the way that people think about the thing in their hands, the thing that they're buying, the thing that they're disposing of? Can we stop blaming the consumer for everything, right? It's your fault. You buy all these things, you throw them away. That's why we have all this waste. You don't throw them in the right bin, you throw them on the ground, whatever. And then can we, as designers and product producers, people that put these things in the world and make quite a bit of money doing it, take responsibility for these materials and what's going to happen to them at the end of their lives? And I think that is such a monumental shift from the way we are doing things now, and the benefits that will be accrued are so much bigger. For example, like 40% of the waste that goes into landfill right now is organics, and it emits methane, and it's just it's like waste, exponential waste, right? Because it could also be processed. You could process it in an anaerobic composter and capture the natural gas offputs and pump them into the gas pipelines, which we do in California and they do across Europe. You could, and then you use the sludge to fertilize your crops. You can do organics, regular aerobic composting, and use that as landscaping amendment. There's all kinds of ways that we could take this now landfill and redirect it, cut down the emissions coming from landfill, and create other products. I'm not delusional, and I don't think that these are really easy business models. I think maybe where the subsidies will have to come into play, or at least the government support or municipal support, would be at the end of life side of things, because like we don't even recycle our electronics, and those are high value inputs, right? Like those, like I was thinking about plastic. The problem with plastic packaging and disposable single-use plastic is it's not a high value thing.
Yeah.
So you can't really make high value things out of it. Like it's
Yeah.
always getting downcycled, right? And I'm watching the progress of recycled plastic because, companies are slow and petroleum has a huge foothold in Washington, et cetera. So recycling is what we always get pushback on. Like, no, we're looking, what will it do to the recycling stream? I'm like, you mean that 5 to 9% of things that get recycled? Like, what, this is going to, we're only looking at recyclable things, right? And so I'm watching recyclates, and I'll be standing in a manufacturing plant and maybe there'll be recyclates being run right next to me. And things that are showing up in this material with pharmaceuticals, heavy metals, all kinds of toxins, right?
Right.
Because
Sure.
they go in
Sure.
toxic and then
And
they come out even more concentrated, right?
and the demand for these plastics, I mean, there's no place to send them or put them at this point because China
Right.
has decided not to accept them. So, and the infrastructure for turning recycled plastics into something else, right, I mean, doesn't exist.
Right.
So again, it's a kind of I don't think it's chicken and egg or cat and mouse is the
No,
right way to
nope.
characterize it. It strikes me that California would be a great place to set up factories since we have this organics collection law, right? That
Yeah.
the food collection, which is going, at least in Santa Cruz, is going to out of county high temperature composting facilities. And
Yeah.
of course you'd have to clean the stuff, but that would make great input, I think,
Yep.
right? For
Yep.
the kind of bioplastics that you're
Yes.
pushing. I mean, it's sort of a mystery, why this is happening this way. But again, it has to do with, I think, with volume and trying to get the stuff out of sight. I mean, the cups are ubiquitous, right? I mean, this is one of the arguments in terms of sort of disseminating awareness and
Mm-hmm.
demand, right? And I'm wondering, is it possible to manufacture more durable products with this stuff? We
Yeah.
all we all have plates and cups and things in our houses, right? And although
Right.
plastic is not aesthetically the greatest thing to have,
No, it's not.
a lot of people have them, right? I mean,
Right.
because of the cost of dining sets.
Yep.
And those then, stay around for a fairly long time. And I mean, it would be great if, you break a cup or plate or something, you can throw it back in the compost pile. Are you thinking
Yep.
about that at all?
Yeah. So, that's a good question. And we did for a while look at making, back when we were working with PLA, and there were some really nice kind of home goods kind of setups, like full plate sets and so forth in PLA.
In PLA or PHA?
PHA in PLA. We worked in
Oh,
PLA
oh,
before
okay.
we switched to, yeah. So in PHA, it's actually an even better application material for a reusable application because it has a relatively high heat tolerance. So you can put boiling water into a PHA or PHBH cup and it won't melt, which is not true about most other bioplastics. They melt at a pretty low temperature. So
Yeah, yeah,
you can dishwash our cups. So we're walking a fine line, right? So I am heavily pitching reusable systems people to help, but we'll co-develop a more heavy duty cup
yeah,
that could be
yeah,
dishwashed and
yeah.
reused, until it cracks or something, and then recycled. Right now, most reuse systems are using plastic, regular petroleum, PP, right?
Yeah, yeah.
Polypropylene. And the argument is that it's robust, it's cheap, and it can be dishwashed, 1,000 times or something. So, of course, the issue for them is that our material is expensive. So, the more robust or durable your container, your product in this food service sort of setup, the more expensive it's going to be because there's more material in it. So that's something we're working on, though. I really do have a reusable and compostable and bio-based dream. I do. I also know that the reusable side is struggling because they have, maybe I think the best average turn for any given container is like 5 before it either breaks, gets lost, or something. That's still way better than 1, but it's not like it's not a really easy business model right now. Water also, as you well know, in California is an issue. So needing to wash, like industrially wash everything, that's an issue. Freight, all the expenses that go into picking all these things up, taking them to be washed, redelivering them. It's a headache to think about. On the other durable goods for home use, yeah, I think we started out with a cup that I lightweighted as much as possible so that we could make it affordable and it could be certified home compostable as well as, so it's certified commercially compostable and it's certified home compostable. If a product is made from the best material in the world, but it's super thick, it's just going to take longer to break down, right? It's going to take more microorganisms longer to eat it. So I really wanted to cross that threshold. I just didn't want to make another even more expensive commercially compostable product and put it on the market. So
you're listening to Sustainability Now. I'm Ronnie Lipschutz, your host. My guest today is Raegen Kelly, who works at Better for All, and we're talking now about the virtues and I guess problems with making more durable plastic items from easily compostable raw materials. Raegen, I can't help but note that you're in California. Water bottles are ubiquitous, right? Everyone has a water bottle.
Yeah.
And it's something that people just take with them. They lose them. They use them. It seems to me that if you could identify some things like that, and you get people to sort of, it becomes normal behavior as carrying water bottles has, right? When I was up at the university, a colleague and I were trying to do this with coffee cups, with reusable coffee cups, and giving them away, try to give them away to students and get them to carry them around. So it's not the industrial scale thing, which is, of course, problematic. It's the individual can clean or not clean their coffee cup as they wish. And there, there's already an existing demand, and the people who carry around water bottles are your audience.
I have this photograph someone gave me maybe 4 years ago, and I love it. It's a young woman on a bike, and she's got her backpack, and she has a carabiner, and the carabiner is clipped through a coffee mug handle and onto her backpack. And I'm like, that is just so cool, and
that was exactly what we were trying to do.
Yeah, I love it. And it is frustrating because our cups, right, obviously can't just easily clipped onto something.
No.
We're taking on the biggest market first, which is hundreds of millions of cups being thrown away, like, daily. And the party cup that can't even be recycled. And all the places in America where you live, little less so where I live, people are pretty aware and they're already sort of integrating these reuse systems into their personal lives. But I would say that, where we have a lot of traction so far is in places like Texas and the Midwest, where they order, red party cups into their homes so they don't have to wash the dishes, which I didn't even know people did that. I was like, oh, wow, really? Keggers and all these things, like people buy 1,000 cups and then throw them away. So that's really like, if we can gain adoption in markets and with people that normally would not be considered friendly or amenable to this kind of thinking, what I'm finding is, in fact, they're thrilled. Like, they're aware. It's not like they're like, oh, whatever, I don't care about the environment. It's like, no, I'm having a party, and how cool, there's this other option. Now I can still have a party and not feel like I'm making such a terrible impact. That's the other thing. The other thing that was kind of surprising is we had cups at a rodeo, and full of working cowboys, right? They were competing and they loved the cups. I never would have seen it coming from a mile away. And they said, well, we don't have waste management. Like, no one comes and picks up our trash. Like, we have to compost basically everything. And the rest we have to drive, 100 miles or 50 miles just to deposit it at the one drop-off point. So we love anything that reduces the amount of waste we need to carry off our ranches. So there's interesting applications out there that I had not thought about.
I'm sure there are. We're getting sort of close to the end of our time. And, I just want to go back to the California argument for a moment. And that is that if you look at, and I did some research into this, if you look at the decline of social smoking, which is smoking in groups, I think it started here, and now most of the world or much of the world bans smoking in social settings, right? And
that is true.
Right. And it's a practice that you don't engage in. And that's my pitch for starting where people are already engaging in certain kinds of practices, as opposed to places where you're sort of just, dropping in. But
I hear you. How about both and?
Well, yeah, I mean, try both, right? Anyway, well, is there anything else that you'd like to add to all of this? I mean, what do you see as the future then?
Well, what I see as the future is like we need to radically reduce our consumption. And that's not something that I'm addressing yet, right? But, I mean, we need to just radically reduce our consumption. And so...
Do you worry then that, you're basically facilitating the continued consumption of what are basically throwaway items? Does that worry you at all?
I think I am participating in that process. Yes. Right now I'm meeting people where they are 100%. But I hope that, the material of the cup embodies an idea that will somehow plant a bug. We just need to, you've already said it in a number of different ways, but we need to start thinking differently about the things that we have previously thought of as trash. So, if you're engaging with the cup that your drink is in, because you're reading on the side that it's a different material and it goes in a different bin, and there is a different way to think about this. And if we do manage to get cups into a robust reuse system, and people are learning to refill, even just refilling your cup, right? Instead of just buying a new drink and throwing the other one under your chair.
Sure.
Every time you do this, you halve the impact of 2 cups, which is small, but we have to start somewhere.
Yeah. Okay. Well, this has been a really interesting conversation, and maybe we can touch base again, in 5 years to see where things stand, and look back at this and, and say, oh, we were naive, or we were very, ahead of the wave. Well, Raegen Kelly, thank you so much for being my guest on Sustainability Now.
It was really my pleasure. Thank you.
If you'd like to listen to previous shows, you can find them at ksquid.org/sustainabilitynow, as well as Spotify, Google Podcasts, and Pocket Casts, among other podcast sites. So thanks for listening, and thanks to all the staff and volunteers who make K-Squid your community radio station and keep it going. And so until next every other Sunday, Sustainability Now.